When we think about Bitcoin, we picture pure code, right? Something totally digital, living out there in the ether. But what if its single biggest threat isn't some super hacker, but something as simple and as physical as a ship's anchor? Because every single transaction, every block that's mined, has to travel through a very real, very physical network. And that network might just have a surprising weak spot.
And that really gets to the heart of what we're asking in this explainer. For all its incredible decentralized design, does the entire Bitcoin network ultimately rely on a physical vulnerability that could, in theory, bring the whole thing crashing down?
Well, here it is. This is that potential weak point. The internet isn't some magical cloud, you know? It's a massive web of fiber optic cables stretched across the floors of our oceans. These things are the real arteries of global data. So if they get cut, what in the world happens to a network that's supposed to be unstoppable?
All right, so let's really dig into this. A pretty amazing study decided to tackle that exact question. They looked at over a decade of network data, from 2014 all the way up to now, and basically ran this giant virtual stress test to see how much physical abuse the network can really handle before it starts to break.
So how do you even measure that? Well, they use this key metric called the critical failure threshold, or PC for short. The easiest way to think about it is as the network's breaking point. It's the bare minimum percentage of those undersea cables you'd have to destroy to disconnect a significant chunk of the network. In this case, about 10% of all nodes. And that 10% number is important, because that's when you'd start to see real-world problems, like block propagation slowing way down.
So what did they find? Well, if we're just talking about random failures, an anchor drags in the wrong spot, an undersea earthquake happens, the network's breaking point is astonishingly high.
And this just spells it out perfectly. Let that sink in for a second. To cause any real significant damage, you would have to randomly cut more than 7 out of every 10 of the world's submarine cables. The network is just designed to find another way around the damage. It's incredibly resilient. But, and this is a huge but, that's only if the damage is random.
And this is where the whole story takes a fascinating turn. See, a random accident is one thing. A smart, coordinated attack is a whole different ballgame. A real adversary isn't just going to start cutting cables randomly. They're going to go for the jugular. They'll target the most critical points.
And just look at the difference here. It is absolutely wild. A random attack needs you to take out almost 3/4 of the entire planet's undersea cable infrastructure. But a targeted attack, the research shows, you could cause a similar level of chaos by just taking down the top 5% of the most important hosting providers. The places where huge numbers of nodes are concentrated. That's so much more efficient and, frankly, a much scarier possibility.
But right as this vulnerability was becoming a real concern, something really unexpected started happening deep inside the Bitcoin network. Something that would completely flip this entire equation on its head. And I'm talking about the quiet and then very sudden explosion in the use of Tor.
Just look at this timeline. For years, running your Bitcoin node over the Tor anonymity network was this super niche fringe activity. You can see back in 2017, it was only 3% of nodes. But then, things started to accelerate. By 2021, it jumps to 23%. And by early 2025, it just explodes to 64%. This wasn't some grand plan. It was a grassroots shift, probably driven by individual users wanting to protect themselves from censorship.
And that brings us to today. The vast majority of Bitcoin nodes are now operating behind Tor's layer of anonymity. They're essentially in the dark. You have no idea where they are physically located, and that has fundamentally changed the very shape of the network. So this leads to the million-dollar question, doesn't it? Your gut instinct might tell you that adding all this complexity, hiding all these nodes, must create new problems, new hidden weaknesses. Does making the network anonymous also make it more fragile when it comes to a physical attack? And the answer, incredibly, is no. In fact, it's the complete opposite. This huge shift to Tor, which was probably all about privacy, has had this incredible unintended side effect. It accidentally gave the entire network a new suit of armor. Okay, so the proof is right here in the data. Look at the ClearNet nodes, the ones not using Tor. Their breaking point is a very respectable 78%. But when you factor in that huge chunk of the network now running on Tor, the entire system's resilience actually jumps up to 86%. That's right, Tor is making the network measurably tougher against a physical attack. So how on earth is that possible? Well, the magic here isn't the anonymity itself. It's the geography of the Tor network. See,
Tor runs on thousands of volunteer computers called relays, and it just so happens that the huge majority of that network capacity is physically located in just a handful of European countries: Germany, France, the Netherlands. These places also happen to be some of the most hyper-connected places on the planet, with an insane amount of internet infrastructure. So what you get is the super redundant, super connected core that acts as a backbone for all those Bitcoin nodes running on Tor.
Okay, let's just pull back for a second and really think about what this means. This isn't a story about some brilliant engineer designing a system perfectly from the top down. No, this is a story about a decentralized system adapting and growing stronger all on its own, with nobody in charge.
The researchers have a great name for this: emergent resilience. It's this incredible idea where thousands of separate people, each just trying to protect themselves from being censored, ended up accidentally building a collective system that is way more resistant to physical attack. It's like a beautiful accident of self-organization.
And get this isn't just some theory from a computer model. The real-world data from actual cable cuts backs us up big time. Out of 68 real verified cable failures over the last decade, a whopping 87% of them had basically zero impact on the Bitcoin network.
I mean, just take this perfect real-world example from March of 2024. A huge undersea event damaged as many as 8 different cables at once off the coast of West Africa, causing major internet outages for 13 countries. It was a massive physical failure. And the effect on the global Bitcoin network? Pretty much nothing. A blip. It was exactly what you'd expect to see from a system with this kind of emergent resilience.
So it all leaves you with this one really fascinating thought. The Bitcoin community set out in search of one kind of freedom, from censorship, and in the process, they accidentally built a totally different kind of strength. It really makes you wonder, as these decentralized systems keep growing and changing without any central plan, what other kinds of invisible armor are they building right now, completely by accident, hiding in plain sight?